Biosand filter Underdrain optimization. This is our group. Me, Harsimer, Rattan, Ramndeep, Khosa, Raveen, Fernando, and Jordan Fleming. We're part of Group 8. I'm going to give you an introduction to the Biosand filter. COST is a non-profit organization that has trained over 5 million people across 164 countries in providing clean and safe water. According to the United Nations, 3.5 billion people worldwide are unable to access clean water that we in Canada are all born with the right to have. We want to find a solution that's affordable and where they can have access to these raw materials without having to go too far or importing them from another country. The solution to this is the Biosand filter. What is a Biosand filter? To put it simply, it's a box with 3 layers of sand and gravel that clean the dirty water by killing the pathogens in it. It includes filtration sand, separation gravel, and underdrain gravel. The separation gravel prevents filtration sand from migrating down and clogging the outlet tube. The filtration sand eventually, after about 30 days, forms a biolayer that cleans bacteria. The underdrain gravel is a layer that prevents the separation gravel from blocking the outlet tube, which brings us to our design problem. The design problem is what we are here to solve. We were tasked with improving the underdrain layer. This means that we have to optimize the underdrain performance through first doing literature review to identify the key aspects of this underdrain and understanding how it works. After that, we have to build a suitable experimental apparatus and manipulate various characteristics of the underdrain to observe and analyze the results. Simply put, we want to figure out what underdrain configuration will give the best results. In the end, after many design concepts, which we'll bore you with when you come to our presentation, we came up with one, the full-scale wooden Biosand filter with a clear plastic side. We chose this filter because it mimics the COST filter. It's easy to observe as it has a full clear panel. It was easy construction because it consisted of 4 walls based on 3 different materials. The downfalls of this design are the durability of the glass, as it is a weak point that can crack or get damaged. Overall, we realized that this filter had the most benefits, so we proceeded with this design. As you can see here, this is the construction process. Top left, we were cutting the glass to make sure that it fit. Bottom right is when we constructed the 3 walls, and bottom right is where we checked that they were all symmetrical and lined up. If you can see here, on the left is where we tried to seal the water from getting out. We faced many challenges with this, and in the end we were able to find a solution that worked throughout the experiment. But you'll have to come to the presentation to find out more about that. We look forward to seeing you at the design fair, showing you our solutions and results, and our recommendations for future presentations.